Hi grade 8 student, how are you? I hope you are healthy and stay healthy until we can meet again. So, today's video is a continuation of last week's video and we are still discussing the same thing, which is light. Last week you already knew the law of reflection for flat and irregular surfaces of objects. And today we will begin with the law of reflection of light on the mirror. So there are three types of mirror. The first is a flat mirror, and then we have concave mirror and convex mirror. Oops, sorry. So I don't need to mention the flat mirror function because you use it every day. I think you have one at least inside your room. And for the concave, if you want to see an example of a concave and convex, then you just take a spoon in the kitchen. The part used to put food is the concave part, and the side behind it is convex. An example of concave mirror is a mirror that a dentist usually puts inside your mouth. Remember the circle one with a rod, and the function is to see places that are hard to see for the dentist, of course. And the example of convex mirror is a vehicle rear view mirror, and this one, of course, I think you can see it everywhere. And each mirror reflection has three properties depending on the position of the object in front of the mirror. So the first one is real or virtual. So you can only choose one, and it is not possible for both to occur together. So what does it mean? Okay, I'll explain later after we reach the third property. Okay, so the second is about the size of the image that results from the reflection of an object. So is it enlarged or reduced or as large as the original object? And third, does the resulting image stand upright or upside down as shown in the previous slide? So, well, we will go back. This one is upright, this one is upright, but for this one is upside down. And so, look at the last line. If the image is real, then the image is inverted, and if the image is virtual, then the image will be upright. Why? Because if you look in the mirror and you raise your left hand like this person, the reflection on the mirror will raise its left hand, but it's on a wrong side if you look at it from your perspective. Remember, in the real world, if you stand facing a person and tell them to raise their left hand, then from your point of view, they will raise the left hand that is on your right, because the left hand of someone facing you is on your right side, right? Remember, left for the person standing in front of you is right for you, and left for you is right for them. So when you look in a mirror and raise your left hand, the hand raised in the mirror is on your left side, and this is contrary to the real world, that if there is someone facing you, he should raise his left hand, which is on your right side. So this property is called virtual or not real because it doesn't match what is happening in the real world. Then what about the real image? If the image is real, when you raise your left hand, the shadow will also raise their left hand, but on your left side. Same with the previous case. So what's the difference? The shadow for the real image is reverse, like on this picture. This one is reverse, right? Imagine you are standing face to face with someone, but this person is standing upside down. His head is at your feet and your head is at his feet. So if you ask him to raise his left hand, then his left hand is on your left side because he is upside down. And because on this case, the left hand will be on your left side and the position is reverse or upside down, and it is same with the real world. We can tell that the real image is always reverse or inverted because this theory. And how is the formation of the image on a flat mirror? First, you have to put the object in front of the mirror. So this one is our mirror and this one is our object. Oh yeah, by the way, sometimes this thing is called flat mirror, but sometimes people call it as plane mirror, but they are same. So first, put the object in front of the mirror, and in our case the object is an arrow. So the world on the left is the real world and this one is the virtual world, and we will start to draw the image formation. So the image formation always start from the top of the object, so it will start from here. And first, the light comes from above of the object straight toward the mirror, so just like this, and because the direction is 90 degrees from the plane mirror like this, if you have a protractor and measure the degree, you will get 90 degrees as the result. So it will be exactly on the normal line, because remember, normal line is the line that is 90 degrees from the surface. So the normal line will be here. And this causes the light to reflect exactly in the direction it came from. So you can see it with the arrow pointing at each other. So this arrow is the arrow for the incident ray and this one is for the reflected ray. And next, the light comes from the top of the object to the bottom of the mirror, so to here. Because the angle is not 90 degrees here, you need to draw the normal line. So this is the normal line. And then measure the angle between the incident ray and the normal line, so this angle. And then put the angle below the normal line, so you need to put it here and draw the reflected ray. So don't forget to draw the arrow. This is for the incident and this is for the reflected. So the image will be at the intersection point of the reflection line. But you see, the first reflection line goes straight to the left, while the second reflection is go down like this, so here and here. So they will never meet in the real world. That's why we must pass on the light to the virtual world to make them meet. So light pass in the virtual world should be on the dash line to make people know that this is the virtual world. So first line is like this because we will just need to continue the reflected ray, so like this. And the second line like this, see, and then they will cut each other on a certain point, and this is where the image is formed, so here. And its properties is upright, and remember, if it is upright it will be virtual in virtual world, right? And the same size for both the image and object. Next we'll talk about the refraction. You can read the definition here. So refraction also occurs in your eyes because your eyes have lens. Without refraction, light will not collect it together and you cannot see. Then what about glasses user like me? Our eye lenses cannot thicken and thin like they should be. For minus eye, they always thicken, and for the plus eyes, they will be always thin. And it means when looking far away, the light cannot be collected properly and the view, for me, will become blurry. So that's why we use glasses to gather the light together so I can see farther. In LASIK surgery, they cut the thick lens of the eye so that it will become thin again, so that it can again be able to see far. And next, on the previous slide, you know the light is bent because it passed through a different medium. If you remember the example of straw looks bent in water, then there are two mediums there, namely air and water. If we see water and air have different densities, the denser an object, then less speed of light passing through it. So every medium has something called a refractive index. So velocity of light in the air is this much, which is 3 times 10 power of 8 meter over second. And because the air is the standard of the refractive index, the refractive index of air will be 1. And index has no units because it is only numbering. And V here is the speed of light when it enters a medium other than air. And these are the indexes you should memorize for the quiz. And if you look at these indexes, you will see that a denser material will have more index. And then in this picture, you can see that the greater the density of an object is, the more the light will bend to the normal line. Remember, if we draw a normal line, it should be here, 90 degrees from the surface. And denser object like diamond will make the light bend closer to the normal line. And refraction only occurs in transparent objects because if objects are not transparent, then what happens is reflection, not refraction. And next we will discuss the dispersion, which is very closely related to the refraction because dispersion happens because of the refraction. So white light or polychromatic light, we call it as poly because white light consists of several monochromatic light. Mono means one and poly means many. And what light passes through the air and it enters the glass medium and then exit and become like this. But why? So first you need to know what waves are. One wave is one up and one down. So a wave will be like from here until here, or from here until here. So it is one up and one down. You can see that the wavelength for electromagnetic radiation in this picture. This is the length of one wave for each ray. So as you go left, the wavelength gets smaller. And what does it mean? It means it is more dangerous. UV, X-rays, and gamma rays, look at the number. This is very small. They are so dangerous because the waves are very short. It is so short that it can mutate your cells and cause cancer because it can cut through your DNA and cause mutation. And if you remember, the prism has a slanted surface so that the incoming light is also tilted at a certain angle. Like this, it is tilted. Then when it comes out of the prism, the light also passes through a sloping surface so that the white light can no longer travel together because they are all separated according to their speed based on the wavelength. So if we look at the previous slide, because one wave for the radio wave is so long and one wave of a gamma ray is so small, it means that the gamma rays will travel faster than the radio wave. And on this case, the red is the longer one and the violet is the shorter one. That's why this one travel longer than this one. This one will travel faster, and because they cannot walk together anymore, they will be separated and become monochromatic color. So don't forget that you have assignment to complete at the end of the session, and I will be online throughout the session to answer your questions. So good luck.